Hello and welcome to Keeping Your Plant Potential Full Series, where we'll be talking about everything fulvic acid related to agriculture. My name is Sean Brenneman. I'm a certified crop advisor with nutrient management for our specialty. I have over 25 years of field experience, and I'm responsible for the Eastern Canada business with BioLiNE Corporation. I live in Alvinston, Ontario, in beautiful Lambton County.
And I'm Jeff Bedard. I'm the Executive Vice President of Corporate Growth and Strategy for BioLiNE Corporation. I was born and raised on a farm in northeastern Saskatchewan, and have been involved in agriculture in some way, shape, or form pretty much my entire life. Currently, I'm living in Watrous with my wife and daughter.
I'll tell you what, Jeff, I'm looking forward to the next several series where we're really going to dig into the heart, help train, help educate people on what fulvics are and what they do and why they're important to farm operations.
Yes, absolutely. I couldn't agree more. And when I first started learning about BioLiNE specifically, the products, the process, it, it came down to the manufacturing. And one of the key items about this manufacturing process was that it's highly pure, a very high quality, and even more important, specifically sized fulvic acid. So it's made from a renewable, sustainable peat-based source. And wherever we ship it to across North America and all over the world, we're focused on one very simple thing. We want to help our growers get more from their crops.
That's a great point. It doesn't matter where you farm in the world right now, Jeff. Farming is getting tougher everywhere. Between climate and weather, margins are getting squeezed. You throw on top of that we're being told in the next 25 years, there's going to be another 2 billion people in the world. 10 billion people total. That's a lot of mouths to feed. And at the end of the day, agriculture is expected to meet and exceed that challenge.
Yeah, I just did the math really quickly. And if you assume that Canada's population is around 38 million, give or take a million, we'd have to increase our population 52 times over the next 25 years.
And you know what? And I thought the lineup at Tim Hortons was bad now. Just wait till then. My goodness.
That's okay. There's more McDonald's out there, and their coffee's better anyways.
Well, I've been with the company now for 4 months, and I've been on several farms. I get a lot of questions about when I'm talking about fulvics and humics because they're fairly new. And so Jeff and I thought, what a great way to introduce this series and talk to people than to have some of these most commonly asked questions. So what do you think, Jeff? Should we dig into it?
Sounds like a plan. Let's go.
I like it. So the first question, what are humic and fulvic acid?
Well, quite simply, they are part of the soil organic matter. And when you look at soil organic matter as a whole, it's made up of humic acid, and fulvic acid. And the human portion is that stable, non-biodegradable part. It's very resistant to further breakdown. And without it, you wouldn't be able to have plants grow. It's the main organic fraction. And it usually accounts for about 70% of the total overall organic matter in healthy soils.
When I think about the difference between, and specifically around fulvic and humic, when I talk to growers, I say, if you're looking to affect the soil and the soil properties, apply humic acid. It's big enough. It can do that, got high exchange capacity, so it can affect the soil. If you're looking to affect plants and plant physiology, you need to apply a fulvic acid, and the right fulvic acid too, right? Because when we talk about acids, there's a lot of different fulvic and humic acids out there that are different because of their source and where they're from, how they're extracted. But really, fulvic acids are the ones that can get into the plant because of how small they are, and they can affect the physiology. So you want to affect the soil, apply a humic. You want to affect the plant, apply a fulvic.
Yeah, when human, humics, fulvics, biggest, smaller, smallest, and then most abundant, less abundant, and least abundant in the soil. So,
and a lot of them have similar characteristics, like the cation exchange capacity. All of them have good cation exchange capacity. It's just the level of exchange that they might have. So it's an interesting field, and let's dig into the next question.
Sure.
What do fulvic acids look like? I see the jug, but really, what does it look like?
Yeah, if you take a look at that molecular structure,
that takes me back to organic chemistry for sure.
Yeah, no, thank you. That gives me nightmares. But quite simply, the presence of carboxylate and phenolate groups, it gives these fulvic acids the ability to form complexes with different ions, like magnesium, like calcium, like iron.
Magnesium, iron. I mean, two very important molecules for photosynthesis and energy in the plant.
Yeah. And without photosynthesis, nothing happens. So yeah, incredibly important, and the other thing is that many of these humic acids have two or more of these groups arranged. So you can enable the formation of chelate complexes, which is important. Those formations of those complexes, it's an important aspect of the biological role of the fulvic and humic acids. And it also, it regulates the bioavailability of the metal ions. And, when you take a look at a very down to earth description of fulvic acid. It's a natural water soluble acidic organic polymer. And it's one of the very subclasses of the humics. And so it's got a very low molecular weight. It's very active biologically. And the elemental composition, it's about 45% oxygen, 45% carbon, and then a little bit of nitrogen and a little bit of hydrogen. And it's this large content of this highly bioavailable oxygen, which makes a fulvic acid such an excellent natural antioxidant.
And that's a great point, because we're going to dig into that antioxidant characteristic a little later on, but probably more in future series. And
Sure.
at the end of the day, this is a picture of a fulvic acid. There's back to the point, there's different sources, there are different extractions. This is just to show kind of what it would look like.
Yep.
But it could look a lot differently. There could be different bonds in there, but this is more of just an example of what it looks like. At the end of the day, fulvic acids, they're considered biostimulants, right?
Yep, that's right.
And really, at the end of the day, a biostimulant, it's just able to support the natural nutritional complexes of a plant without looking at the actual nutritional component of the stimulant itself. So they've got characteristics that they're able to really affect that physiology of a plant.
Yeah, absolutely. And so that begs the question, what do fulvic acids do?
Absolutely. Well, I know for sure one thing, that at the end of the day, plants would not be able to exist without fulvic acids. That's clear and above. There'd be no animal or human life on Earth without fulvic acids. But what else do you like to talk about? That's important. What else do you like to talk about?
When I was first, learning about fulvic acids myself and doing some research multiple times, I came across the term, the miracle molecule. Yeah. And when you look at this list, there is a lot of different things that a fulvic acid can do, but there's a couple that really stand out to me. And the ones that stand out to me, the most is the increased natural defense, abiotic stress reduction. That's huge. We live in an environment where, for plants and for humans alike, there's always stresses out there. It's not a lab. And
healthier plants are able to withstand those stresses better as well, right?
That's exactly right. Yeah, it's like it's a natural, your plant is like its own natural fungicide, right? It protects itself better. But the other thing is, of course, when we're planting crops, what are we doing? We're putting down all the nutrients that crop's going to need throughout its growing cycle. And if we can add a product like BioLiNE that can enhance the uptake and transport of those nutrients from the soil, from the solution that you're spraying on it, into the plant in an available form, that's critical. It's so critical.
Well, let's dig into these two a little more depth, because these are the two that I focus on when I'm on a farm as well: the abiotic stress and the nutrient uptake and transport. I love this pictorial. It's maybe not completely accurate because the chemicals, the nutrients and the bonds don't quite work this way, but it expresses the point to say, when you add a fulvic acid and it's moving in and out of the plant through the roots and back into the plant through the exudates and back in, it's bringing in nutrients with it. Or if you put it with a foliar fertilizer, it'll complex with that foliar fertilizer, get more into the plant, because it's small enough, it's able to pass through that cell membrane and actually get into the plant.
Yeah, you go back to that sizing, and I'd never really, had anybody focus on that before when they were explaining fulvic or a humic acid to me, but it makes a lot of sense. The smaller, and I guess to put things into perspective, the nutrient molecules are even significantly smaller than the fulvic acids are. So the fulvic acids can bond in large volumes of these nutrients and carry them through. And
not just anions, cations as well, right? Like the way it's structured, it can pull in cations or anions in the plant.
Yeah, it doesn't matter if it's positively charged, negatively charged. Fulvic acid can bond to it, which is it was a good thing. And ultimately, the volume of these nutrients that we can help this plant absorb and utilize, over the course of a growing season. I mean, That's the goal, right? Everything that we're putting in the
Absolutely.
ground every year, we want that plant to use to grow the biggest, highest yielding crop you can, and obviously, just as important is the quality of the crop.
Let's look at the next one. We're talking about that antioxidant, or that ability for
Yeah,
that plant to defend against stresses out there.
yeah,
I love this slide here.
yeah. It makes a lot of sense. You look at this, and obviously, this is like they added calcium chloride, and when you added calcium chloride, sodium
Sodium
chloride.
chloride, yeah,
Yeah, and
salt.
you add
It's
salt.
basically added salt to the mix there, right? What
Yeah,
plants don't like? Well, plants like some salt, but they don't like a lot of salt. And
yeah.
you
I like
see
it. I like it on my popcorn, but not on my
Yeah.
plants.
Well, and you see the growth difference here, right? When you add a stress. So what we're trying to do in
Yeah,
the lab here is mimic a stress. And they
yeah,
did this through salt injury. So we added the sodium chloride there. And then we also added BioLiNE, our fulvic acid, with the same salt. And look at the growth differences there. So by adding the fulvic acid, it's able to just regulate that plant better, able to get through that stress and continue to grow more normally.
yeah. And spending my life in agriculture in the West, western part of Canada, salinity is present
You've
pretty much
got some
everywhere.
salt issues out there, don't you?
We certainly do. Yeah.
Yeah, and not only that, how many people, edges of fields, right? I mean,
Hmm.
those municipal trucks are out there spreading salt all year, edges of fields. Maybe it's not going to be across the whole field, but you'll see parts of fields that are going to have some definite salinity issues.
Yeah, and just throughout the natural, topography of fields due to, water either laying there or not, or hilltops or stuff like that, it influences the soil biology, and unfortunately, salinity becomes an issue.
Well, and that picture, we made the stress by adding the sodium chloride, but it doesn't matter whether
Yeah,
it's drought stress or water stress or heat
yeah,
stress,
good point.
herbicide stress. I mean, it's a natural antioxidant. Its ability to help that plant reduce the ethylene content, get through that
Yeah,
stress, and just continue to grow more normally. It's pretty astounding what it can do.
yeah, it's a fight to keep the ethylene and abscisic acid levels from
Yeah.
spiking in tough conditions. So,
Next
um,
question we got here is, and
good
and
one.
I like this one here because if fulvic acids are naturally occurring substances, which we said they were, right? They're
Yep,
naturally
that's
occurring
right.
substances. Why do I need to add them back in? Why do we need to add these back in, Jeff?
Well, quite simply, you think cultivation, the picture on the left there, you think of leaching, erosion. They all play a part in the removal of fulvic acids from the soils. You think about the forests, right? They've got a wetland environment. There's lots of roots and fungus. They're holding all those nutrients in place. There's lots of high fulvic, levels that are caught up in that eco web. And I think about, when you break land and you plant your first few crops on that,
Fence
the amount of
row,
nutrients. Yeah, yeah,
fence row
exactly. And
effect, right?
that's a good
Yeah.
way to the fence row effect. Those first few crops, are really, really good. But as production drops off over time, as you remove more of those nutrients, fulvic acid is just one of those things that gets removed as well. And so for land that's been in consistent production, unfortunately, because they are, they're so available in the soil, but they move very easily, you lose them. So we need to supplement them.
We just to your point there, we're losing them. They're invaluable to high plant production, high yields,
Yeah.
and we're not trying to replace them all, but we're just trying to supplement what's there at the end of the day.
Yeah.
And I like the picture. You look at that picture of the forest there. You've got new plants, you've got decaying plants. It's a cycle, right? It's taking it up and releasing it back in. And at the end of the day, what we're trying to do is supplement the fulvic acid in your net soils already to just help that plant
Yeah.
do more, be more, and go from
Yeah.
there.
Exactly. It's the circle of life. Got to be careful. I guess we don't need Disney after us, but yeah.
Yeah. All right. Another question here. I tried a humic fulvic acid 3 years ago and didn't see a benefit. What's your
Yeah.
answer to a customer that says that to you?
And this is a common question. And so I like to try and dig into it a little bit more, get more information. What are you trying to accomplish? What's the issue you're trying to address?
Hmm.
Is it nutrient use efficiency? Is it abiotic stress? Is it crop quality? I mean, obviously everybody's trying to increase yield. Those are all important questions to ask and target, and so those are the first ones that I would try and get to the bottom of.
And in future episodes, we're going to dig into that yield component, because a lot of our long-term research, we're seeing a 75% of the time good return on investment when applying our BioLiNE Gold fulvic acid. But it's not all about yield. It's never all about yield. Yield pays the bills, and it's really important. But again, can I enhance my root system? Can I help that plant get through a weather stress event better? At the end of the day, hopefully that equates into more yield. But it's really those other factors that we're looking at and saying, what are you really trying to accomplish here, and how can a fulvic acid help you realize that issue and be the solution you need?
Yeah, yield equates to revenue, and ultimately you want to generate as much revenue as you can. That's a goal for everybody. But so, reallocating those resources as needed, that nutrient use efficiency, maybe we're able to get you a little bit more, or maintain and use a little bit less.
With what's going on in the fertilizer markets now, every ounce we can squeeze out of them, I mean, is all the better, right? And it's likely long term, it's not going to get better. So
there's very few, I don't know what the proper word would be, I guess the sectors, businesses, part of the economy where efficiency is, focused on more so than agriculture. We're not in the business of wasting time and money. And so, a product like BioLiNE can help keep that efficiency level increasing.
That's a great point. Well, that's the end of our first series here. I think it went pretty well, Jeff. What do you think?
Not too bad. Not too bad for a couple of rookies.
Hey, well, we appreciate everyone joining us here. And really, this is the first of several series. So please, if you have questions, if you've got comments, send them to info@biolinecorp.ca. And you know what? If you're lucky enough, maybe Jeff or I will read your questions on the air. Until the next time, I'm Sean.
And I'm Jeff.
Thank you very much for watching.
Take care, folks. Have a good day.